and I am one of the research director at WRDS. Today we're going to start recording a series of e-learning sessions we call Empirical Finance at WRDS. Thank you for watching. Hello everybody, this is Rui, and I'm one of the research directors at WRDS, and the research director at WRDS trying to create a series of online lectures. We so far call, as you can see on screen, is going to be called Empirical Finance at WRDS. And basically this series of lectures, online lectures, is designed for the starters, first year, second year PhD student, advanced master student, and undergraduate even, to do their empirical finance work at WRDS. And so, for example, you can replicate. I mean, that's what I'm planning right now. So you can learn how to replicate or implement the well-established research, empirical research, for example, from a French 3 factors, which is I am doing. And but before we get into the formal lectures, and we decide to provide another series lectures before that lecture we call Ground Zero. It's basically tell you how to use the WRDS results most efficiently and accurately. So today I'm going to talk about alternative ways to access WRDS. And so let's give you so there are ways to access WRDS. For example, the most intuitive one could be the web query, but there are other ways we keep talking about, which we keep saying is more efficient, and we highly recommend our user to do, but it's not, it's not as intuitive as the web query. So today we decided to do a demonstration based case study here, and to show you how to use those alternative ways to access WRDS. So let me give you a big picture. So you basically can think WRDS has a big computer or a group of big computers. We collect the data from different data vendors, and we SaaSify, basically transfer the data from in different format to SaaS format, and we host the data into our servers, and then we connect the server to internet and provide different ways to let our user to access those data. For example, the most intuitive one is web query, and which is not obviously today's topic. And the second one is something I call SSH/SFTP WRDS interface. Basically, this one is more like a Unix command line interface, but is offer you quite some flexibility. I'm going to talk about those details. I mean, each of those interfaces later today. So and the next one is going to be a PC SaaS Connect interface, which is basically connecting your local SaaS to our server through your PC SaaS on your PC, and the Unix SaaS on our server. So you're basically downloading you're basically running your code interactively between your local PC and remote server. And the next one is something relatively new. It's called SaaS Studio. It's not platform dependent, and you can basically run the SaaS code through web query through a web browser, but actually the code is running on our server. So let's talk about pros and cons for each particular interface. The PC SaaS Connect, obviously the advantage of this interface is basically it's interactive, so it's easy to debug and monitoring what's the code exactly doing. And but the cons is you need, first of all, you need a PC SaaS license, and you need a stable internet. For PhD students, SaaS is kind of cheap. It's still $100, but I know for the institutional investors, the price is much higher. And SaaS Studio is quite similar. You can do coding interactively, and the beauty is, at least as far as I know, for academic researchers or institutions, you do not need any PC SaaS license. And The problem is you also need a relatively stable internet to do this. And the next one is SAS Unix interface, or SSH/STP interface. The benefit, the most outstanding part for this interface is you don't need a very quick internet, and but the problem is it's not interactive. You cannot exactly know what you are doing, and what kind of data you are generating, and in which stage your code is running. So today I'm going to I'm going to show you how to use each of those alternative ways by using a case study. The case study today I'm going to use is how to match corresponding compute data by using QSIP. And on the right of the PowerPoint, you can see I believe this is a physical stock, and which I cannot be sure, but you can see on the stock on this physical stock of Yahoo, you can see something called QSIP. This is identifier for this particular stock. So there's things you need to know about QSIP. So QSIP basically is a security identifier, and is a 9-digit alphabet numerical code, and covers corporate stocks and bond, government, municipal, and international securities. And the format of QSIP is quite interesting. And the first 6 digits or characters are issuer code. Issuer code means for company or government or for any international identity. So and the next 2 digits is something called issue code. The 2-digit issue code combine the first 6 issuer code indicate security, particular security. And the last one is something called checksum. This is an old legacy code, at least from our perspective. For most academic researchers, this is kind of useless. Basically, this is a tracking code for to make sure you get the first 8 digit or character correct on the way of communication. And so their problem is QSIP, of course. And the major problem is QSIP is not permanent. Permanent means if the security change somehow, the QSIP could, for example, if the company change its name, change its location sometimes, and it change its capital structure, the QSIP going to be changed. And for example, Dell changed its QSIP from 24702510 to 2470R10 at 2003. So, but the good part for QSIP meanwhile is it's not reusable. For example, if a QSIP was dropped, I mean, for example, the 24702510, it will never be reused for any other securities or even for the same securities. And the different ways of bookkeeping, that's another issue when you're trying to use QSIP to match different databases. For example, when you're trying to match, there are differences. For example, the CRISP, for example, CRISP retains all historical QSIPs. And for example, in QSIP, it's keep the 2 Dell QSIP in the history altogether. But on the other hand, compute data fundamental only keep the most recent QSIP, i.e. the 2470R10 QSIP, rather than the previous one. So it's going to create some problem, but luckily the QSIP is not reusable, so it's not going to create much trouble as ticker or company name did. And so this is the QSIP matching logic. Terminal ID, so before I'm talking about the QSIP matching logic, so we need to talk about something about permanent IDs from different databases. For example, CRISP using terminal, something we call terminal for security level identifier. It is not only non-reusable, it's permanent. So as long as the security is the security, the terminal never changed. And for company level, they have Permico, which is a permanent and non-reusable identifier for company inside of crisp universe. And compute data use JV key for firm level permanent identifier. And also in compute data, they have a little bit secondary. They have a secondary ID is called IID. So the JV key plus IID actually represent a particular security for a company, and with the JV key. So the idea is easy, and this is pretty. The first case is pretty much the logic I'm going to use for demonstration purpose. So for Yahoo terminal, which is assigned as A3438, is linked to a particular QSIP 9843310. And another thing is for the difference between QSIP and between CRISP and compute data is compute data use 9-digit numerical and alphabet character for QSIP, but CRISP only use the first 8-digit or characters. So so you link the first 8-digit from CRISP QSIP, from compute data QSIP with CRISP QSIP, and basically you link the terminal of Yahoo to the JV key plus IID from compute data. And so there are at least 3 ways I'm going to show you today, but I'm going to focus on the first case. And basically the case 2 is firm to firm. You basically match the issuer level issuer part of QSIP, i.e. the first 6 digits in QSIP between compute and CRISP. And you can also merge terminal by using the first 6 digit in QSIP with the first 6 digit in QSIP in compute data. Either way, you can match those 2 databases. And so we're going to talk about SAS implementation, and basically I'm going to focus on SAS implementation rather than any other alternative venue through different software packages. Okay, let's get into the SAS implementation part. So I'm going to demonstrate how you implement the idea of those kind of matching CRISP and compute data by using QSIP through different alternative venue to access words. Okay, next I'm going to talk about how to implement the idea, the logic through SAS. Use different venues, alternative ways to access words. And so before I do that, so let's go through a little bit SAS code here. It's very short SAS code, and let's do it one by one. So the code here is basically trying to link terminal and JV key together by using QSIP. And so before we're doing anything, I'm just defining a permanent library called demo under my home directory demo folder and slash SAS data folder. So basically, it's basically SAS data is basically a subfolder of the demo folder under my home directory, and so I'm going to save all of my file there actually. But the thing is, this code only generates one particular data or table. So I'm going to go through line by line here. So I use proc SQL or SQL procedure from SAS, and basically I create a table or data called QSIP match, and I save it into a permanent library called demo, which defined before. And I only select terminal and from CRISP data, and JV key from compute data, and I use the table called MSE names from CRISP annual file, and I get the JV key from compute data security table, and basically I use interjoin, basically, which means the intersect between two tables. And the condition of matching is basically required the unQSIP, which is the historical QSIP in CRISP, not to be empty, and the unQSIP must because unQSIP is from CRISP, which is 8-digit or character identifier. I need to use substring function from SAS to restrict the first 8 digit of QSIP, which from compute data to be the same one with the historical QSIP in CRISP. And then I restrict all securities to have 10 and 11 security code from CRISP, which basically restrict the universe into US common stocks. And the result should be all CRISP US common stocks with GV key from compute data. And so here is just before I get into the code, and here is the way you look at the data. So the first part, if you want, I'm talking. So here I'm focused on PC SaaS Connect approach first. So before you do anything, you need to have a handshaking protocol here. You can just always copy paste this particular paragraph into your source code, and the yellow code, the yellow part is actually the part I just demonstrated, and but before you trying to actually run this particular code, you should put an rsubmit in front and an rsubmit at the end, so to make sure your local PC SaaS understand this is a part of code you want to run remotely. And then after you run everything, don't forget to sign off. After you sign off, anything you didn't save in a permanent remote library going disappeared from the remote computer, remote Unix server. Okay, I'm going to do a demonstration here. I'm pre-coding a SAS code called lecture 1 here. It's including all relevant information. Okay, so the first part is going to be the handshaking part. You're running it by clicking the little running man above and enter your credential. Alright, so right now you link to Words Cloud. I'm using Words Cloud for this demonstration is because Words Cloud is the next generation of Words server. It's providing 1 GB personal permanent space, disk space for each individual user, and up to 500 GB disk space for each subscriber or each institution. So, let me make this one a little bit bigger. So we already log in Words Cloud server right now, and this is exactly the code I show you on the slides. So you click the little running man again, basically submit the code. So you generate a QSIP match. It's quick. You generate a QSIP match table and save it in a remote folder called demo. And because this demo folder is remote, you cannot exactly seeing it in your local PC machine without doing anything. But you can download the data through a download procedure. You can just remember you running proc download and upload. Those two procedures are actually running remotely. So you need to put rsubmit in front and rsubmit at the end of the procedure. So here you download the demo. You download the CRISP. You download the compute state match table under demo library into a local file called test1 under your working library in your local PC. So you can open it. You can see this is the file actually you generated remotely by using PC SaaS Connect. And actually there are a few tricks. You can use the local, make it much easier to use remote library. The first one is actually, if you know where is the remote directory is, you can basically use this particular command, and it's actually going to connect. It's going to connect one of your PC local library to we call reference. It's actually reference one of your local PC library to a remote library, and which is in this particular remote location. And so if you open this library, and you can see there are a little bit computer and somehow network over there. Is basically saying you are this is a remote library. You open this particular library, you can see this is the file you generated with the code above. And there are another way. Sometimes you, as I will show you later, you do not exactly know where is the physical location of the remote library you're trying to define. You can use this. You can use this particular command. Let me delete this one first to show you they are working the same way. And you run this one again. So you're going to see this R demo here again, basically showing you this is slimref basically means server library reference. Basically, you refer your local a local library called R demo to the demo library in remote SaaS environment. You can also use this upload command to submit the local file to a remote file. If you click the upload procedure, you can see what I'm doing here is basically I upload a file called ts1, which actually the QSIP match file I created and downloaded previously. And you upload this particular file to the remote demo library and use the same name called test1. And if you click the button here, click the library here, you're going to see this file is uploaded. The next one is kind of easy because this upload and download sometimes create a lot of, you need to write at least rsubmit and unrsubmit and proc upload and download is kind of not very convenient to use, especially nowadays. People can use the remote library reference like I was told you before, and you can treat the remote library as one of the local library in your local PC. For example, you can use this particular date step to get the remote file to your local file directly. So just running this code, like you run any particular code in your local machine, you can see in your working library, local working library, you have test2. And the test2 is going to be identical with test1 because they are actually a different copy of the very same file match QSIP. And so the next thing I'm going to show you is sometimes, that's what I usually prefer. You do not, you just want to create some small file in the remote server and download it into your local server and working locally. And you can do this. You can create a table. And if you do not put any permanent remote library over there, is this QSIP match going to be generated in a local a remote temporary library. How can you get the data from remote working or temporary library? It's not easy as on the surface. For example, after you're running this, you cannot see anything here refer to any remote library. But as I showed you, there are tricks to do that. Basically, you use as server library reference option for lab name command, and basically if you run this particular line, and you're going to have a local library reference to the remote work library or temporary library. You open it, you can see this file. This file is what you generate here, and there are another trick you can do is you can actually refer a remote, you can refer a local library to be a remote library by using inherit lab option for the rsubmit command. Basically, what this do is this particular option tell the remote server to create a library reference called PC work, which is actually the local PC local PC SaaS work library. So It's basically if you saving anything remotely by using this PC work library, it's going to be saved automatically into your SAS, local SAS, local SAS working library, or any library you want to define in the inherit library part. So you should have something here called QSIP match, and which is actually a code generate remotely and push back to your local PC. So usually this is the way I work. I mean I work almost every day, but I do not recommend you to download big data in this way unless you have very stable network, very fast network. Otherwise, maybe I mean the communication, the transfer of the data transfer may be interrupted in the middle, and you may lose all of your data. And so remember, if you sign off from here, anything you didn't save remotely going to disappear. And so you can see all of the remote libraries you use, all of the libraries you use to refer remote libraries disappeared after you sign off. But the one you put into your physically local library are still survived. So the QSIP match and T1, T2, all three of those are the same thing actually for the very same logic. And those are remained. So after you sign off, you can work completely locally. So the next thing I'm going to do, the next thing I'm going to I'm going to show you is PC SAS Connect. So if you log in first now and you make it bigger, and you go to get data, there's something called SAS Studio here, and you need to log in again by using your SSH credential. This particular interface is totally operating system independent, so you can run. Technically speaking, you can even run it in a iPad. I don't think this one supporting smartphones, but any tablet should work for this particular interface. You can see physically. You can see this is my home directory. Under my home directory, I created a folder called demo. Under demo, I have a SAS data a subfolder, and I was saving everything there, and I just deleted for the demonstration purpose. And you open. So right now you don't need to deal with any rsubmit and ursubmit or there's a connection PC SAS connection trick because you're running everything naturally remotely. And you go to the web query and you copy paste the code. I used exactly the same code I used for the PC SAS Connect demonstration. You're running this one. So you're going to create, so okay, first thing you need to check is whether you have error message or not. Obviously you do not have error message here. And if you want to look at the thing in a library view, you can see I have all of the I have access to all of the words data, so that's why I have so many different libraries. And but the first line of my code is again I defined a local library. This is not local. I defined everything is running remotely. Right now, there are no such thing called local or remote. So I download everything. I create a folder. Create a library called permanent library called demo, and I save the QSIP match file here, and you can open it. The beauty of SAS Studio is you can not only see the data in a library perspective. You can actually open the file, just in our file management. It's just like folder perspective, and so you can open the file. Same thing here, and it's going to be exactly the same file. And another another wonderful part, another part I like this particular interface is if you go back to SAS library, sometimes, and when you run empirical work, sometimes you need to use different software packages. For example, I use Stata a lot for regression analysis. And what you can do is you can output SAS data you generated through SAS server into different format as the way you want. I mean, they have pretty much different options. And for example, I want to save it to Stata. And you just choose the format and click export. It's loading the libraries. So everything should be done right now. So you can see you have a QSIP matched data file here. You can click download file. And also, I mean, you need to go back to folder. You cannot do it inside the library. You can also go to you can also download the file in the way here. And so if you can open this Stata file, it's like very native Stata. So you can start you can start next step, for example, regression from here. And but you can also download the SAS file in the way you just created. So this is SAS viewer, but you can pretty much open it with standard SAS program if you have a PC SAS program. There are a lot of interesting features in SAS Studio. I'm not going to cover much. Today I'm just trying to open the door to let you guys know how to use in general SAS Studio and other venue to access words. And the next thing I'm going to show you is going to be SSH or SFTP interface of words. So let's start with SFTP interface here, and you can download this particular file and this particular SFTP file transfers software called FileZilla. And what you need to do is you basically put the server information here, and your credential. You can actually create a profile to connect to the server. You can save it in save this particular website into one of your profile. You can reuse it in the future. And remember, just for the simplicity, the part for SSH is going to be 22. So you're going to receive a message about the credential. So here is basically my home directory. As you see, I have a demo folder here, and I have two subfolders here. One called SAS code, the other one called SAS data. I just created a QSIP match data file, and the SAS QSIP match file I generated through SAS Studio. And just let me show you how to transfer the data from remote server to your local server, a local PC or any local computer. You can this on the left hand side. This is my desktop. It's basically something here, and you can transfer it here from here just by dragging, and you can transfer it here to here just by dragging, and you can change the name of your remote of the file in remote server, and also you can upload the file from your local computer, and you can delete them very easily. You can create a subfolder. Anything temp. You can delete a subfolder. This is the beauty of this SFTP. Is pretty straightforward, and it's very intuitive. And if you want to download some big data, you can just let the server and let this particular software packages let this particular software to help you to download the data. The next thing is I'm going to show you the SSH interface. The SSH interface is a little bit probably the most complicated one. I already have the server saved. So, but let me delete it and uh, let me create a new session. So it's going to be SSH. I'm just trying to show you how to initiate a session. Words cloud working open edu and then your username, and then you can simply create a session, and it's automatically connected because I somehow entered my credential before. And this particular software I like very much recently. This one is called this one is called uh, Mobile Xterm, personal edition. You don't need, it's free. You don't, it's like FileZilla. You don't need to pay anything for that. And you also have, I mean, this the beauty of this software is you combine SSH interface with SFTP interface somehow. You can see the file here, and so you basically can delete files here, you can create files here, but meanwhile you can do SSH here. So for example, you can enter ls. Basically, if you do not know anything on Unix, just Google it. This is very basic stuff. ls is basically listing all of the files and folders under the current directory, and you go to demo, and then you can see by using ls again, you can see you have two subfolders, SAS code and SAS data. We just go to SAS code to see whether there anything inside there. It's nothing. As you can see from here, SAS data is empty. So let's go back to the parents, the demos directory, and and then you can see you go back to here and you go to SAS code, and you list the files. You can see a remote SAS file. The remote SAS file is exactly, I can show it to you here. It's actually the code on the slide, the SAS code you want to run on the server on the slide. So you can use the SFTP here, go to the SAS code part, you delete everything here. You can, I think this one is already deleted, so that's why it's still here. Let's refresh. Okay, you can actually drag this file here. So you have a remote SAS file here. What you need to do is you cannot type something SAS here, because this is once again, next generation of our Unix environment. We provide the user a much better option called QSAS. QSAS basically running the SAS code you want to run, and leave it into the leave it on the background, and you can log off. You don't need to worry about it. And if it's going to create the file and save it for you as long as you did everything right in the SAS code. And you enter remote, so you're running it. And because the code itself is very small, it should be done now. So if you go back up here and you go to SAS data, see, it's created. And so the beauty of this environment is when you trying to programming something going to run hours on even days, I strongly recommend you to use this interface because this is totally trouble-free. No human interaction is required. You basically can submit the code, forget about it, and come back several days later to continue your research. And what I usually do is I usually start with a subset of big data. And so as long as I make sure the code, I'm running some either PC SARS Connect or even SAS Studio to make sure my code is running correctly, and then make the thing much bigger. I remove the restrictions on number of observations and make it into a big SAS, make the file to deal with much bigger data, and I submit the code I want to run on remote server through SFTP or SSH and to run it here. And okay, that's pretty much I want to talk to. I want to teach for the different alternative ways to access SAS, Words data, to access data at Words. Okay, here we have the last thing we need to do is a homework. So I already show you how to match the terminal and GV key by using 8-digit QSIP. And how about you do homework by linking terminal and GV key and IID through 6 digit of QSIP or characters, and so 6 digit. Once again, I need to count here. To link the GV key and terminal by using 6 digit numerical and how about you match terminal and GV key by using 6 character or digit of QSIP between GV key and terminal. In the next ground zero lecture, I'm probably going to talk about the different ways to match, what is the best way to match crisp and compute data, and especially benchmark the way to match different ways to match crisp and compute data, benchmark the result on CCM. Hello, that's pretty much for today. Thank you for watching. Please leave comments and your contact for support, and see you later.